Hello everyone, this is Group 5 and today Mohammed Mrigdad and I, Kenneth Fahad, will be presenting on biometric attendance system using facial recognition. So let's go through the agenda. So I will be introducing the topic. I will talk about biometric attendance and facial recognition systems and what's the problem statement that we have focused on our study on. And then I will talk about the solution proposal, how we are trying to solve the problems. We'll see some advantages, disadvantages of facial recognition system, and go through some industry best practices and standards. After that, I'll talk about the system architecture that we are proposing. I will give you an overview and the requirements and just try to walk you through the workflow, how this thing is going to work. Then Mirdad will continue with explaining you the implementation process. He will dive deep into the requirements analysis and deployment and talk about some security issues for the system. And then he will move on to the compliance and privacy issues that we have identified and tried to address. And at the end, he will conclude the presentation. So let's start with the introduction. According to the US Department of Homeland Security, facial recognition technology is a contemporary security solution that automatically identifies and verifies the identity of an individual from a digital image or video frame. This is an important definition because it highlights the security aspect or use case of facial recognition systems. To understand how this technology operates, let's break it down into three main stages: capturing, creating face print, and matching. The first step is capturing. The technology begins by identifying the details of a face from a digital image or video frame. As you can see in the image provided, the unique facial data is highlighted by a network of points. These points are the key features that the system recognizes, such as the distance between the eyes, the shape of the cheekbones, and the contour of the lips. Next, we move to the creation of face print. This step involves converting the captured facial details into a unique digital representation. Think of it as creating a face print but a fingerprint but for your face. The system analyzes the unique facial data and transforms it into a mathematical formula or a face print. This face print is a digital code that represents your face's unique features. The final stage is matching. The face print is then compared to a database of known face prints to find a match. This is where the verification process occurs. If the system finds a matching face print in databases, it can confirm the individual's identity. This comparison can happen in real time, making it an incredibly efficient method for identity verification. Facial recognition technology is utilized in various fields. It enhances security in airports, helps law enforcement agencies track and identify individuals, and is even used in unlocking smartphones. Its ability to provide quick and accurate identification makes it a valuable tool in our increasingly digital world. Facial recognition technology represents a significant advancement in security and identification systems. By capturing facial details, creating unique face prints, and matching these against a database, the technology provides a seamless and efficient solution for verifying identities. As we continue to advance technology, facial recognition would undoubtedly play a more significant role in our daily lives. Now let's focus on the problem statement. Manual attendance system in education institutes are inherently time consuming, prone to errors, and susceptible to fraud. The traditional methods of marking attendance can lead to inaccuracies and administrative burdens, creating inefficiencies that affect both educators and students. By integrating a biometric attendance system using facial recognition, we can ensure reliable and tamper-proof attendance tracking transformation the way institutions manage attendance. Unauthorized access and fraud in educational settings pose severe risk. These threats can lead to compromised student records, unauthorized grade changes, and even identity theft. Such security breaches erode trust in the institution and can result in significant financial as well as reputational damage. It is crucial to implement robust security protocols to safeguard against these threats and protect sensitive data. To combat these threats, there is a pressing need for enhanced authentication measures. By utilizing biometric systems like facial recognition, institutions can ensure that only verified individuals have access to sensitive information and facilities. Let's talk about the solution. Manual systems in educational institutions, as we have learned, that they are prone to different kind of threats, like they are time consuming, error prone, and susceptible to fraud. Unauthorized access and fraud in educational setting can lead to severe consequences, including data loss and breaches. To combat these threats, the solution will introduce advanced authentication techniques through facial biometrics to to verify individuals and protect sensitive information. So, implementing a biometric attendance system using facial recognition will also help automate and secure the attendance tracking process. This system leverages advanced facial recognition technology to identify and record student attendance in real time, and thereby enhancing accuracy, preventing fraud, and streamlining administrative tasks. Let's look at some of the industry best practices that we got to know during our research for this proposal. So there's first let's look at the set of standards by ISO IEC. The first one is 19794-5. So it is the biometric data interchange formats, which provides the specifies the formats for encoding, recording, and transmitting facial image data. The next one is 30107-3. This standard provides guidelines for detecting and mitigating presentation attacks on biometric systems, including facial recognition. Then there's 2382-37. It defines terms and concepts related to biometrics, including facial recognition. And the last one in ISO series is 30136. This standard addresses performance testing methods for protecting biometric templates, ensuring data security and integrity. The National Institute of Standards and Technology also has some guidelines and standards. The first one is NISTIR 8312, which provides benchmarks and performance metrics for evaluating facial recognition algorithms. The next one is NIST's Special Publication 80063-3. It includes guidelines for implementing biometric systems, including facial recognition as part of the digital identity verification. Let's focus on advantages of biometric attendance systems using facial recognition. The first is accuracy. Facial recognition systems provide high accuracy by using unique physiological triads, eliminating the risk of proxy attendance and maintaining integrity of attendance records. The second one is security. These systems enhance campus security by restricting access to authorized individuals only. The third one is efficiency. As it automates the attendance process, it saves time and resources, reduces administrative workload, and minimizes human errors. The fourth one is operational efficiency. This technology fosters a secure and reliable environment, positively impacting the overall educational experience for both students and staff. It supports a more disciplined and accountable academic environment. Now let's focus on the disadvantages of the system. The first one is privacy concerns. Collecting and storing biometric data raises significant privacy issues. There is a risk of misuse and unauthorized access to sensitive personal data. The second one is cost. Implementing a biometric attendance system can be expensive. The costs include purchasing and maintaining the necessary hardware and software, as well as training staff to use the system effectively. The third one is technical issues. Facial recognition systems can sometimes produce false positives or negatives, especially in cases of poor lighting, low quality images, or changes in the person's appearance. These inaccuracies can undermine the system's reliability. The last one is ethical concerns. The use of facial recognition technology can lead to ethical dilemmas, including concerns about surveillance and the potential for discriminatory practices. Ensuring the technology is used fairly and responsibly is crucial to addressing these concerns. Now see how the solution is developed, and I'll try to explain the system architecture. Let's begin with discussing the functional requirements. The first one is the user authentication. The system should ensure secure user login. This is crucial for maintaining the integrity and security of user data. The second one is image capture. The system captures facial images using device cameras such as laptops, tablets, and webcams. This live input is essential for accurate facial recognition. The third one is the facial recognition process, which recognizes to identify users. And then it's attendance recording. Once the user's identity is verified, the system automatically logs their attendance in the database. User interface. The solution provides a web or mobile interface for both students and instructors. This allows users to interact with system, view attendance records, and manage data efficiently. Now let's focus on some non-functional requirements. Scalability. The system is designed to handle an increased number of users and data, ensuring it can grow with the needs of institutions. Performance. Fast and accurate facial recognition is crucial. We have optimized tried to use some optimized algorithms to ensure quick processing times and high accuracy rates. Security is a very important concern. Protecting user data and ensuring privacy is the top priority of the system. And maintaining system availability and operation is essential. So we have developed some redundancies and failover mechanisms to ensure continuous operations. For usability, providing an intuitive and user-friendly interface is key to user satisfaction for this system. Now let's dive into the architecture of the system. Users can access the systems via laptop, tablets, and webcam. These devices serve as the primary input source for capturing facial images. The web mobile application is built using HTML, CSS, JavaScript, and frameworks like React.js and Vue.js. This ensures a responsive and interactive user experience. The application server uses Node.js, Express.js, Python, OpenCV, and these technologies handle facial recognition processing in an efficient way. The databases that are used are MySQL or Mongo database, and the storage relies on cloud computing like AWS S3 or Google Cloud Storage. Now I would request Mohammed Mriqat to continue the presentation. Thank you.
Thank you, Kenny. Now let's discuss with implementation process. Implementing a biometric attendance system involves a structured approach comprising 6 main steps: requirement analysis, system design, development, testing, deployment, and maintenance. Each step is crucial to ensure the system functions correctly and securely. Let's explore each of these steps in detail. In requirement analysis, this step involves gathering and defining both functional and non-functional requirements by consulting with stakeholders to ensure all needs are accurately captured. Second one, system design. Create detailed design including system architecture, database schema, and security measures, specifying components and their interactions, and planning robust security protocols. Next step is development. In development phase, deploy the front-end user interface and back-end server logic. Integrate the facial recognition library or API for accurate biometric data processing. Next is testing. Conduct comprehensive testing, unit, integration, system, security, user acceptance, performance, and regression, ensuring the system operates correctly and securely. Next is deployment. Set up the production environment, deploy the system, migrate existing data, and train users. Continuous monitoring ensures performance and security post deployment. Next is maintenance. Perform regular updates, security patches, and enhancement. Continuous monitoring and maintenance ensure long-term operational efficiency and security compliance. Security measures. Ensuring the security of a biometric attendance system is paramount. Key security measures include data encryption. Both in transit and at rest data should be encrypted using strong encryption standard like AES 256. Next is authentication and authorization. Implementing multi-factor authentication or rule-based access control ensure only authorized users can access the system. Next is data integrity. Use digital signatures and hash function to verify data integrity. Then secure data storage. Encrypt biometric data in database and secure backup storage. Next is physical security. Secure all hardware components against tampering. Then privacy protection. Ensure data minimization, anonymization, and user consent to comply with privacy regulation. And the last one is network security. Deploy firewall, intrusion detection system, and network segmentation to protect against unauthorized access. Testing procedure. Testing is a critical phase to ensure the system works correctly and securely. Testing procedure include unit testing. Verify the functionality of individual component using frameworks like JUnit or PyTest. Integration testing. Ensure that integrated components work together using tools like Selenium or Postman. System testing. Validate the complete system against the requirements through comprehensive test plan. Security testing. Identify vulnerabilities using tools like OWASP, JAP, or Group-5 and perform penetration testing. User acceptance testing (UAT). Engage end user to test the system in real world condition and provide feedback. Performance testing. Measure system performance under load using tools like Biometric and Load Runner. Regression testing. Retest previously executed test case to ensure new changes do not adversely affect existing functionality. Deployment and maintenance. Deployment involves setting up the production environment, including hardware and network configuration. The system is then deployed, and any existing data is migrated to new system. Continuous monitoring is essential to track system performance and security. Regular update and maintenance, including software patches and security update, ensure the system remains secure and efficient over time. Compliance and privacy. Compliance with regulatory standards such as GDPR, CCPA is crucial to protect user privacy. This involves implementing data minimization practice, anonymizing biometric data, where possible, and obtaining explicit user consent before collecting and processing biometric data. Adhering to these regulations not only protect users but also build trust and ensures legal compliance. User training and awareness. Effective user training and awareness programs are vital for the success of the system. Security training helps users understand best practice for protecting data. Regular awareness programs keep users and administrators informed about the latest threats and mitigation strategies. This helps ensure that everyone involved in the system is equipped to maintain its security and effectiveness. In conclusion, the implementation of a biometric attendance system using facial recognition requires careful planning, robust security measures, and thorough testing. Each phase of the process, from requirement analysis to deployment and maintenance, plays a crucial role in ensuring the system is secure, reliable, and user friendly. Continuous improvement and monitoring are essential to maintain the system effectiveness and adapt to emerging threats and technologies. Here are some references. Thank you.